Hi, this is Karen from the University of Connecticut.
This is Brittany from Florida Southern College.
Eric from State College of Florida.
So today we're going to show you what patch plates look like after the fact. So previously we demonstrated the patching technique where you take unique colonies from your initial soil isolation and patch them onto a plate. Here's a great example of a patch plate. This is done on PDA media. And so you can see the diversity in types of colonies that we have. We have some white and fluffy, some yellow, some orange, and all of these are patched using that same grid system we did previously so that we have isolated patches of the colonies. Here's another example. This is actually the same example. So we have two plates that were done, and you can see some things to watch out for. It looks like the plate might have been on the wet side here. So as you can see, we have not as clean definitely as our initial patch over here is. So something to watch out for. We want to always make sure your plates are very dry before you do pretty much any of the techniques that we're going to describe in this lab to avoid this. And particularly for the patching, you don't want your colonies to patch to merge into one another, because then it's very difficult to distinguish between them. And you don't know if you have one type of organism or multiple types. Alright, so let's take a look at what happens after we screen for antibiotic producers. So what we have here is an example of a spread patch plate, where we have spread plated a tester strain. In this case it was Pseudomonas putida, which is one of the safe relatives of the escape pathogens, in this case Pseudomonas aeruginosa. So we spread plated the Pseudomonas putida in the background and then patched the colonies from the patch plate onto this plate after it had been allowed to dry for a significant period of time. And as you can see here, we do have one zone of inhibition down here, indicating that the organism that was patched right here is producing a compound that's inhibiting the growth. And you can see that because there's no growth right around there's no growth of the background strain here, no growth of the background Pseudomonas putida. Every other patch plate has growth right up to it. You can see that with the beige color. Sometimes it's better to hold this up to the light, but here you can actually see it very clearly. Now if we look at this same group of tester strain, or same group of patch plates that were this time tested against E. raffinosa, which is another one of the safe relatives of the escape pathogens. In this case we actually don't see that zone of inhibition. Now the growth of this organism is a little fainter than Pseudomonas, but when you hold it up to the light you can see it pretty well. And if you look, you'll notice that this is the same organism that we saw the inhibition before. We don't see that same inhibition. So what that tells us is that this organism that's patched here is able to secrete a compound that inhibits the growth of Pseudomonas, but not our E. raffinosa. And so this is the organism we'll want to go forward with to try to identify what the organism is. So the next step would be to take this organism not from this plate but from the original master plate and quadrant streak for isolated colonies, or any other method of streaking for isolated colonies that you might use, in order to see two things. One, that it's a pure culture, and two, to actually get ready for doing the colony PCR. And here's an example of what that might look like as far as isolated colonies. Not a fantastic example, but in this case they did quadrant streak this organism out, so we do have isolated enough colonies to distinguish that this is a pure culture and there's not more than one type of organism present in the patch.